This is CPM Precalculus Chapter 3, number 74. So here we want to use triangle RAT at right. So here's the triangle to complete the following problems. So part A says to find the exact length of side RA in terms of n. So let's look at the triangle here. Here we have RAT, right? So that's why it's triangle RAT. Across from angle A, I'm going to label this side A, so that's equal to 2n. Across from angle N, I'm going to label, across from angle T, right, this is angle T, I'm going to label this little t. Across from angle R, I'm going to label this little r. Okay, so where is side RA? Well, RA is right here, which is the same as side T. So this is equal to side RA. Okay, so how do we find the length of side RA, or T, right? I could even write T, in terms of n. Well, if you look at the other two sides, they are both in terms of n. This is 2n and this is n. And we can see right away that this is a right triangle. We're told that angle A is a right angle. So we can use the Pythagorean theorem. Right? And we know the Pythagorean theorem tells us c squared is equal to a squared plus b squared. But more specifically, c is the hypotenuse, right? C is the hypotenuse of the right triangle. And we know that looking at our triangle, the hypotenuse is always the longest side, which is also the side opposite the right angle. Okay, so we know hypotenuse here is side A, which is 2n. Okay, so let's fill that in. We know instead of c, I'm going to write 2n, and that is squared, equals 2. And then A and B here are the other two sides, and it doesn't matter which one is which. So R I'm going to call A. So A is just side R, which is n, so it's equal to n squared, plus B squared is the other side, which is our RA. So I'm going to call that, let's call that T. So that's T squared since it was B squared. Okay? So let's go ahead and square this. We know that the square goes to both the 2 and the n, so that's 2 squared is 4, n squared is equal to n squared plus t squared, right? Subtract n squared, now we're just solving for t, so subtract n squared from both sides. You get 3n squared is equal to t squared. Now let's go ahead and square root both sides to get t alone. So we get t here is equal to square root of 3n squared. Well, n squared cancels with the square root, so we could put that in front. So it's n square root of 3. Okay? And we know t is the same as RA, so that's, we could say RA is equal to n square root of 3, and it's the length of a side, so we can say units if we would like. Units. Okay? Let's go on to part B. Alright, so part B says to use the triangle and find the ratios of sine, cosine, and tangent of angle R. So here's R. So we're looking at sine, cosine, and tangent of angle R. So the memory tool that helps us know the ratios for all of our trigonometric functions is Sohcahtoa. Right? So S here stands for sine. So we know this one is just OH, right? So OH means O over H, or opposite over hypotenuse, right? Cosine, we know is here, is the C. This is sine, cosine, and the T is for tangent. Cosine is AH, which is A over H, or adjacent over hypotenuse. Oops, that's 2 H's, hypotenuse. And finally, tan is OA, which is O over A, and O stands for opposite, and A stands for adjacent. Okay, so let's substitute these in. So sine of R then is the opposite side from angle R. So the opposite side is here, right? And the length of this side is n. right? R is equal to the length of n. So let's go ahead and say, well, the opposite is n divided by hypotenuse. We remember the hypotenuse is the longest side of our right triangle, which is 2n. Simplifying that, n over n cancel out, so we just get 1 over 2. So sine of angle R is 1/2. Cosine of R, so again, we're looking now at the adjacent side to angle R. We know angle R here is made up of these two rays, or these two sides of the triangle, right? One of them is the hypotenuse, the other is the adjacent. So this one is side RA or T, but we know that that is equal to n square root of 3. I'm going to write that there, n square root of 3. So that's equal to n square root of 3 over hypotenuse again is 2n. The n's cancel out and we get square root of 3 over 2. Okay, so the cosine of angle R is square root of 3 over 2. Finally, we have tangent of angle R. Tangent we see is opposite over adjacent, so we look at the opposite side, which is n. So write n. The adjacent side, remember it's not the hypotenuse, it's this side over here, n square root of 3, which is just 1 over square root of 3, right? The only thing we might want to do is rationalize this fraction by getting rid of any roots in the denominator, right? Rationalizing the denominator, so we're going to multiply by the root in the denominator over itself, because that's equivalent to 1. 1 times square root of 3 is square root of 3. Square root of 3 times square root of 3 is 3. Okay, so written better, this 1 over square root of 3 is square root of 3 over 3. Cosine of angle R is square root of 3 over 2. Sine of angle R is square root of, no square roots, just 1 over 2. Okay, so finally let's do part C. Using part B, okay, we just did that up here. Find and simplify sine divided by cosine of R. What do you notice? So let's go ahead and do that first. Sine of angle R divided by cosine of angle R. Well, sine of R we did, and that was 1/2. Divided by cosine of angle R we did, and that was square root of 3 over 2. Okay? So now we have a fraction divided by a fraction, and remember that's the same thing as multiplication by the reciprocal of the denominator. So the reciprocal is going to be 2 over square root of 3. That's going to be 1 times 2 is 2. 2 times square root of 3 is 2 square root of 3. The 2's cancel out, and we're left with 1 over square root of 3. But again, it looks just like tan of R. We want to rationalize that denominator, so we multiply square root of 3 over square root of 3. That's equal to square root of 3 over 3 without the square root, because square root of 3 times square root of 3, you get rid of the root. So what do you notice? Well, we kind of said it already. That's equal to tan of angle R, right? Here we have it. And so we know they're equal. In fact, let's take this a step further. Okay, so that's done there. Let's kind of look at this in terms of Sohcahtoa. Okay, we know sine is equal, sine of an angle, let's go ahead and write an angle, is equal to the opposite over hypotenuse, right, O over H. Cosine of some angle, this is just the angle symbol right here, is equal to adjacent over hypotenuse. Tangent of that same angle here, right, is equal to the opposite over adjacent. But is it equal to also, let's put a question mark, is it equal to the sine of that angle, just like we have up here, sine of R divided by cosine of that angle? Well, I put the question mark because I'm going to go ahead and simplify the right side and see if this is true. Sine of the angle we know is opposite over hypotenuse, divided by cosine of the angle is adjacent over hypotenuse. This is a fraction divided by a fraction, so I'm going to write opposite over hypotenuse times the reciprocal, means hypotenuse in the numerator, adjacent in the denominator. These cancel out then, and we're left with opposite over adjacent. Okay? And now we can see that they are both equal, right? Tan of an angle is equal, so yes it is, let's go ahead and write that. Yes it is equal to sine of the angle divided by cosine of the angle. Alright, so we just kind of showed a proof here as to why tangent of some angle is equivalent to sine of the same angle divided by cosine of that same angle. Okay? This is the proof. And that's going to end for us CPM Precalculus Chapter 3, number 74.